passive transport. Okay, so in the PowerPoint on Monday, I talked about diffusion, I talked about membranes, I talked about selective permeability, I talked about osmosis. We'll talk about, this is a lab that is done with sheep blood. So the things you got to know, we measure solutions. One way to measure the strength of a solution is a percent solution. So if I put 5 grams of glucose in 100 milliliters, that's a 5% glucose solution. We also use a mole. A mole is a certain amount of a compound or a substance. So a 1 molar solution will have 1 mole of a salt. So if you put 58.5 grams of sodium chloride in a liter of water, that's a 1 molar solution, because 58.5 grams is a mole of sodium chloride. You will not have to calculate any of things. You just have to know that a molar solution measures the relative concentration of a substance in water. Okay? So in your body, we have milligrams or milliosmoles of substances. So a millimolar solution would contain a fraction, 1/1000th of a 1 molar solution. The concentrations in the body run around 300 millimoles. Okay? So osmosis is the diffusion of water through a selectively permeable membrane and is caused by the unequal distribution on 2 sides of the membrane. If a solute cannot cross the membrane, it's non-penetrating. Water is able to penetrate and to be drawn to the side with the higher solute. So if I have a high concentration of salt, water will move to dilute that solution. Osmolarity is the measure of the number of particles in solution. So if I have 1 molar solution of glucose, the molar concentration equals the osmolar solution, the osmolarity. If I have a 1 molar solution of sodium chloride, since sodium chloride dissociates or breaks into 2 particles in solution, it's a 2 osmolar solution. If I have calcium chloride, the calcium chloride dissociates into 3 particles. So if it's a 1 molar solution of calcium chloride, it will be 3 osmolarity. So solutions can have the same molarity but different osmolarities. So organic compounds like glucose do not dissociate. When you dissolve glucose in solution, if you heated it, it would still be glucose. If you dissolve sodium chloride, it would taste salty, but when you evaporated all the water, new salt crystals will form. But just notice that inorganic molecules such as sodium chloride and calcium chloride, 1 molar will have twice the osmolarity because sodium chloride breaks into 2 solutions when it dissolves. Calcium chloride dissociates into 3 particles, so its osmolarity is 3. Okay? Non-penetrating solutes, the higher the osmolarity, the greater the osmotic pressure. Okay? Let's look at a diagram now. Make sure you read through all this other stuff. So if I have extracellular fluid of 300 milliosmoles and intracellular fluid of 300, these are isotonic solutions. 300 equals 300. Osmosis will occur, but some water will move in, some water will move out. They will have no net movement. On the other hand, suppose you have this situation. The extracellular fluid is 250. The intracellular fluid is 300. So there's a higher concentration of dissolved materials. So water will move from the outside into the inside, and this cell will swell and burst because there's more water in this extracellular fluid because it has less solute. So if this were a sugar solution of 250, water would move into the cell and cause the cells to swell and cause the cell to break. Hemoglobin would leak out and you'd have a ghost. So hemolysis is when if you put red blood cells in a hypotonic solution. So if the amount of dissolved material is less compared to the inside of the cell, water will move to balance the situation and it'll cause this cell to burst. So if this is a red blood cell and it's put in a hypotonic solution because the 250 is less than the 300, the cells will undergo hemolysis and break up and they'll become dysfunctional. If you put red blood cells in a hypertonic solution, 350 has more dissolved solute compared to water, compared to the inside. Water is going to leave the cell, so the red blood cells are going to shrink and look lumpy, and they will crenate. Okay? So when you get an IV, you want to make sure that the concentration of the IV solution is the same as the concentration in the red blood cells or in your tissues. So that's why 0.9% sodium chloride is used, because its concentration is similar or equal to the concentration of your blood plasma and your tissue fluids. Okay? So we're not going to be able to do this experiment. So don't worry about any of this. So lipid-soluble molecules are nonpolar. They can diffuse through the lipid membrane. Other molecules that are polar have to pass through channels. The passage of substances depends on their size and their charge. Small nonpolar molecules will pass through the membrane faster. If it's larger, it's going to take the small nonpolar would pass through the membrane faster than a larger polar molecule. Polar means the molecule has charge. Nonpolar means that it has no charge. So make sure you read through all of this and know what hypotonic means and hypertonic and non-penetrating and so on. Any questions? Okay, Let's minimize that. And we'll stop presenting. Stop recording, rather.